AB Calculus Homework Help, the Fundamental Theorem of Calculus. This is a short homework assignment I gave today. And it's not going to be due for a little bit of time now with the break underway. But it'll be these 5 problems. These problems 1 through 5, starting 1, 2, 3, and then 4, 5. And we're going to work on the problems 6 through 10 immediately after our break. But what I'm going to want to do is work out this problem 2 and also talk a little bit more in depth about the fundamental theorem of calculus. My students have this t-shirt here whose front side is this graphic here. It's going to be a white print on a black t-shirt. There are the integral from 0 to 1 of 8 x cubed dx kinds of people in the world. And that's the front of the t-shirt. The back of the t-shirt is this: those who understand calculus and those who don't. So what we have is, this is the definite integral or fundamental theorem of calculus. We have the integral from 0 to 1 of 8. I'm going to take this coefficient 8, put it outside to the left of the integral symbol. And integrating x cubed dx, we have x to the 4th over 4, and we multiply that by the 8 out front, and we evaluate between x equals 0 and x equals 1. Well, the 8 over 4 reduces to 2, so we have 2x to the 4th power evaluated from 0 to 1. And so fundamental theorem of calculus, if we have a function, we say this function here is little f of x, and we integrate, we get a big, let's say we integrate from f of x dx from a to b, we get big F of b minus big F of a. Okay, let's work this out. We have 2 times 1 to the 4th power. This is big F of b minus 2 times 0 to the 4th power. This is going to be f of a. And this simplifies. 2 times 1 to the 4th power is 2. And then this would be, f of a will be 0. So this is our answer. So therefore, there are 2 kinds of people in the world: those who understand calculus and those who don't. And graphically, what it looks like is this. We have a variation of the cubic function looks like this. Okay. So between x equals 0 and x equals 1, graphically, it's this slice of area we're talking about here, between the curve and the x-axis between 0 and 1. So that's what it looks like. One thing I highly recommend that you take a look at is I recently completed this video in my note card series, AB Calculus Note Card 62, which goes over in more detail the fundamental theorem of calculus. You can access that quite easily. Okay, let's go back to this problem 2. We're going to have integral from negative 2 to 3, and what we're going to have, we can split, since these are 2 separate terms. We're going to have x dx minus the integral from negative 2 to 3, 5 dx. And working to the right, we get integral of x dx is x cubed, or x squared, excuse me, over 2. And we're going to have minus integral of 5 dx is 5x. And we are evaluating between x equals -2 and 3. So working below, so I'm bringing down here to the down a row and to the left. We're going to have our big F of B, which is going to be in place of x will be 3. So you have 3 squared over 2 minus 5 times 3. Okay, so this is going to be our f of b, and then we're going to subtract out our f of a. Our f of a is going to be, I'll subtract and put a big parenthesis here. We're going to have -2 squared over 2 minus 5 times -2. And we will just simplify from here. Okay, we have 3 squared is 9. So we have 9 halves. And we have minus 15, which is going to be 15 is 30 halves. And why did I change this into halves? Because this denominator here of a half. Next, we're going to subtract out. We have -2 squared over 2. That's going to be 4 over 2. And then we have minus 5 times -2, which is going to be plus 10. Well, 10 is going to be 20 halves. And continuing to work below, we have 9 halves minus 30 halves. And we have minus, what we're going to have is we have 4 halves plus 20 halves. So we subtract out 24 halves. And working to the right, we're going to have 9 halves minus 54 halves, which is equal to -45 halves. And this is our answer to problem 2. Problem 1 should be very easy. Should be as easy as that t-shirt problem. 3, you can split this into 3 integrals. Problem 4, you can square out this thing, expand it. If you take the 2x minus 5, make a binomial expansion, you'll get 3 terms. You'll get 4x squared minus 20x plus 25, something like that. And this one here, 5, you're going to get from 2 to 3, 4x to the -2 power plus 1 dx. Okay. Should be able to get all those right. And then we're going to proceed to more complex problems. After the break, good luck and thanks for viewing.